Hello, quick explanatory video of the different forms of the standard deviation formula that we use in our calculations. Well, let's start off with the mean. We know that that is the sum of our x values, and then we divide it by n. Sometimes it's written in this form where you've got the sum of the x values multiplied by their frequencies, then all summed up, and divide by n. Very similar approach for variance, where we've got our x values and their distance, their deviation from the mean, the x bar. Then we're going to square it. We're going to sum that lot up, and then we're going to divide by n, sometimes written with the frequency there. So how do we get the other forms that you see in our tables? Okay, so if we start with our formula we were just looking at here, we've got this bracket here with a square, isn't it? So we can expand the bracket out. So we're going to get our xi squared term, our middle term 2xi times x bar, that's like a constant throughout here, and then we get our x bar squared. Then we can start moving this sum at the front through into each of those different elements. And so our first term here is just the sum of our xi squared. Second term, we've got our sum of xi, but we had our 2, so we've got our 2 and our x bar here, which are constants throughout the sum, so they can come out the front. And then we've got our x bar squared here from above, and of course that's a constant all the way through the sum. So if we're summing that, oops, sorry, there we go, we're summing it, we're going to be summing it n times, same constant n times. Before you know where you are, we've got our term we're looking for here. There's our sum of x squareds over n, and then we've got these two terms here that are going to be very similar, because our sum of xi over n is actually x bar, isn't it? That's the definition of it. So if we come down here, we've actually got 2x bar squared there, and we had 1x bar squared, the positive one there. So 2 minuses and a plus. So lo and behold, we're left with our term here, our first term, which is our sum of xi squareds over n, and then we're with our minus x bar squared, which you'll see in your formula book, and we quite often see it in this form here as the variance is. All of that written over n, that means they've got to bring the n up here, because of course it cancelled out there. There's no n here, is there? So of course that can be used as well for our sum of squares calculation, which is going to be quite important when we start looking at n minus 1 in the next video. So our sum of squares is that first term, our sum of our xi squared, and then our sum of x bar squared times n. Now we sometimes see this written, rather than being as a form of x bar, with that x bar expanded again back into the sum of x over m, and of course we can take this n out of the bottom, and that would be n squared, wouldn't it, when we take it outside the bracket, and we've got an n there, so they cancel, and we're just left with that n there. So the other way you'll see it in the formula books is the same for first term, and then the second term's got the sum of xi squareds and then divided by n. Personally, I think it makes more intuitive sense in this form here, isn't it? Because we're making our adjustment for our x bar there. So there you go. How about that? That's your basics. In the next video, we'll talk about where the n minus 1 comes from.